Hello everyone, last time we have stopped here. So this is about now we have seen about measures of association. Measures of association parameters are important for measures strengths of association is the one is relative risk. The second is odds ratio, and the third is attributable risk. The fourth is attributable risk percent. The fifth is population attributable risk. The sixth is population attributable risk percent. So now we will left for parameters, that means attributable risk, population attributable risk, and its percentages. So now we will start about attributable risk, or we can say risk difference. So now we'll start this one. AR means attributable risk. ARD means risk difference. Attributable risk is a measure of association that provides information about absolute effect of exposure or the excess risk of disease in those exposed compared with those who are not exposed. So attributable risk means it measures about the absolute effect of exposure or the excess risk of disease in those exposed compared to those who are not exposed. So the other is attributable risk is used to quantify the risk of disease in exposed group that can be considered attributable to exposure. So risk difference quantifies the risk of disease in exposed group that considered attributable to that exposure by removing the risk of disease that would have occurred anyway due to other causes. That means it will estimate risk of disease in exposed group due to that exposure. If it is smoking, due to smoking, but it will not consider risk factors or exposures other than smoking or one risk factor. So this is an important estimate. So attributable risk incidence attributable to exposure or attributable risk is equal to incidence in exposed group minus incidence in non-exposed group. So after subtracting non-exposed group, we will get the incidence in exposed group due to that risk factor. So this is a very important concept. So this table shows the data from cohort study of oral contraceptive use and bacteria among women aged 60 to 49 years. So this is individual with bacteria, individual with no bacteria. So this is total. So this is OCP, individuals exposed for oral contraceptive, and this is no OCP, individuals no exposed for oral contraceptive. So this is exposed group, this is non-exposed group, this is having bacteria or disease group, this is not disease group. So so this is the question. So how you calculate attributable risk? So attributable risk 27 over that means the formula is incidence in exposed group minus incidence non-exposed group. So incidence of bacteria in exposed group is 27. Incidence of bacteria in non-exposed group is so in this case 482. So we can divide 27 over 482 this is incidence in exposed group. This is incidence in exposed group, means 27 over 482. 482. So the next one is this is 27 over 482. The next one is 77 over 908. So this is incidence in exposed. This is incidence in exposed. So incidence in exposed means 77 over 1908. So this is incidence of bacteria in non-exposed. This is incidence of bacteria in non-exposed. So 27 over 48 means incidence of bacteria in non-exposed. 77 over 1908 is incidence of incidence over non-exposed. So we can calculate. By the way, it's similar to calculating relative risk. Relative risk incidence is 27 over 4. Incidence is 27 482. So now by dividing 27 over 482, 77 over 908, so we can get 0.01566. So this is known as attributable risk. So to remove the decimal, too much decimal, we can multiply by 100,000. So attributable risk in this study is 1,566 per 100,000 oral contraceptive users. So this is an important concept and how to calculate attributable risk. So interpretation: the excess occurrence of bacteria among oral contraceptive users attributable to their oral contraceptive use is 1,566 per 100,000 oral contraceptive users. So this is excess occurrence of bacteria due to that's attributable to their oral contraceptive use. It does not include other risk factors. So example 2 is this is CHD disease group, this is non-disease group, this is exposed group, this is non-exposed group, this is exposed cigarette. So after this, incidence of disease is 28. This is incidence of in non-smokers is 17.4 per thousand. So this is, by the way, incidence. So if you divide this one by this one, this is a relative risk. But if you subtract this one to this one, it is what? Attributable risk. Attributable risk is risk difference. So incidence in smokers which is attributable to their smoking is, or attributable risk is equal to incidence in smokers minus incidence non-smokers. So 28 minus 70.4 is equal to 10.6 per thousand per year. So this one is subtracted to this one. So this is a very important concept. So attributable risk calculated in this way. Attributable risk, the third example is attributable risk is equal to incidence in exposed minus incidence in non-exposed is equal to risk difference. So this is CHD, yes or no. This is smoking, yes or no. So incidence in smokers is 84 over 3000. This is 84 over 3000. So this is known as 28 per thousand. This is also incidence in non-exposed is 87 by 5000. 87 by 5000. So it will come 70.4. So this is known as incidence in non-exposed group is known as background risk. So now attributable risk is equal to 828 minus 70.4 per thousand. That means 10.6 per thousand. That it is to give more explanation for previous example. So you can calculate attributable risk just like this. So how to interpret it? Among smokers 10.6 of 10.6 of 28 per thousand incident case of the CHD are attributable to the fact that those people are smoke. So that means CHD comes due to smoking. Only calculated among smokers 10.6 of 28 per thousand incident case of CHD that occur could be prevented if smoking were eliminated. So since we calculated due to smoking, so due to smoking 10.6 is comes. So if stop smoking, or if we became non-smokers, this incidence will be prevented. So this is very important concept. So this is all about the attributable risk. Now we are starting about attributable risk percent. Attributable risk percent is the fourth parameter. Eliminates the proportion of the disease. Estimates the proportion of the disease among the exposed that is attributable to exposure, or the proportion of disease in exposed group that could be prevented by eliminating the exposure. Now the proportion is calculated. So attributable risk percent is equal to incidence in exposed group minus incidence in non-exposed group over incidence in exposed group times 100. So this is known as attributable risk percent. Now the difference is we divide by incidence exposed and multiply it by 100. So from the attributable risk, so incidence in exposed minus incidence in non-exposed over incidence in exposed times 100 is known as attributable risk percent. So an example for attributable risk percent is attributable risk percent is equal to incidence in exposed minus incidence non-exposed over incidence in exposed times 100. This is known as etiologic fraction. So now it is a continue from the previous example. So diseased, non-diseased, exposed, non-exposed. So incidence in exposed group is 84 per 3000. So an incidence comes due to 28 per 1000. So incidence in non-exposed is 27 over 5000. So it comes 70.4 per 1000. It's background risk. Now up to this one is similar with attributable risk, but now 28 minus 17, this is incidence in exposed minus incidence in non-exposed over incidence in exposed. 28 times 100, we will get 37.9%. So in another way, 28 minus 17 over 28 is equal to 37.9%. So among smokers, about 38% of the morbidity due to CHD may be attributable to smoking. So among smokers, 38% of the morbidity due to CHD could be prevented if smoking were eliminated. So 38% is due to smoking. So if smoking is prevented, 38% will be eliminated or prevented. So this is known as attributable risk percent. So refer the previous table, calculate attributable risk percent. So attributable risk percent, incidence in exposed minus incidence in non-exposed over incidence in exposed times 100. So in previous example, 1566 over per 100,000 over 27 over 482 times by 100, 27.96%. For this is an example taken from oral between bacteria and oral contraceptive use. So having this concept, having this concept, if oral contraceptive use causes bacteria, about 28% of bacteria among women who use oral contraceptive can be attributed to zero oral contraceptive use, and can be eliminated if they do not use oral contraceptive. So about 28% of the disease or bacteria comes due to oral contraceptive use. So if that woman is non-oral contraceptive user, 28% will be absent or eliminated. So this is another example. So attributable risk percent is completed. Now we will see about the fifth parameter, population attributable risk. Population attributable risk among the exposed and non-exposed, or example total population. So how much of the disease that occurs can be attributed to a certain exposure. So population attributable risk and population attributable risk percent, they are measures of the amount of disease that would be averted if the whole population was unexposed. The whole population is different. So the measure the amount of disease that would be averted or that would be prevented if the whole population was unexposed to that exposure or risk factor. So population attributable risk is equal to incidence in the population minus incidence in the population minus incidence in unexposed. So in another way, attributable risk times proportion of exposed. So this is incidence of unexposed, this is incidence of exposed in the population. So we want to estimate how much of the burden of the diabetes among Ethiopians is attributable to obesity. Attributable to obesity due to this risk factor. So the whole population is a very core concept. So population attributable risk is calculated by using incidence in the total population minus incidence in non-exposed. So this is diabetes, this is weight, obese, exposed, slim, non-exposed, yes, is with diabetes, no is no diabetes. So incidence in the total population means 1 over 1,100. 1,100 is this one, over 10,000. So this one divided by this one, incidence in the total population. So the point is 0.11 or 110 per thousand. Incidence in non-exposed is 250 over 5,500. That means 250 is this one, 5,500 is this one. So 250 divided by 5,500. So this is slim, non-exposed. So this one is exposed, this one is non-exposed. The exposed in total population, this one is non-exposed population. So now we have the 0.0455, so 45.5 per thousand. This is background risk. Now population attributable risk is equal to 110, this one, 110 minus 45, this one, 45.5 divided by 10,000. So is equal to 64.5 per thousand. 64.5 per thousand. So this is known as population attributable risk. Population attributable risk is 64.5. So in general population, 64.5 of in the 110 per thousand incidence case of diabetes are attributable to obesity, meaning 6.4.5 was due to obesity. So in general population, 64.5 of 110 per thousand incident case of diabetes that occur could be prevented with sufficient weight loss. So if you lose weight, sufficient weight, we will prevent 64.5 of 100 per thousand incident case. So in population attributable risk, we said in general population, but in attributable risk, we said in exposed population. So population. Now the last type of parameter which measures the strength of association is population attributable risk percent. Now population attributable risk percent is calculated as incidence in the total population minus incidence in an exposed population over incidence in the total population. Times by 100. So this is the same example. Now incidence in the total population is as we have seen 0.11 or 110 per thousand. Incidence in an that means this one over this one, and incidence in an exposed population is 5,250. So I mean 250 over 5,500. So we will get this one. So that means 45.5 per thousand. This is known as background risk. Now population attributable risk is 110 minus 45.5 over 110 times 100. We will get 58.6%. So population attributable risk percent is equal to 58.6%. So in the population, in the general population, about 59% of the case of diabetes may be attributed to obesity in the population. So if we 59% of the case of the diabetes could be prevented or averted if Tampa residents lost sufficient weight. So that population, if they lost weight, 59% of diabetes will be prevented. So this is an important parameter. So now a very essential concept is this one: possible outcomes in studying the relationship between disease and exposure. The outcome may be no association between exposure and disease. So when to say no association between exposure and disease, the odds ratio should be 1, the relative risk should be 1, and attributable risk should be 0. And to say positive association between exposure and disease, that means there is direct relationship between exposure and disease. The odds ratio should be greater than 1, the relative risk should be greater than 1, and attributable risk should be greater than 0. But to say negative association or inverse association between exposure and disease, in this case, to say this, odds ratio should be less than 1, relative risk should be less than 1, and attributable risk less than 0. Less than 0 means negative, less than 1 means fraction. So we will get this like this. So when there is negative association, more exposure, less disease. That means inverse relationship. When we are more exposed to the exposure, the disease will be less, meaning the inverse relationship or protective. In the case of positive association, more exposure, more disease. If you are exposed to more exposure, you will get more disease, meaning if you exposed to smoking, if you smoke daily and too much amount or too much dose, you will get the disease too much. You will exposed to lung disease too much, or coronary heart disease too much. So this is direct relationship, this is inverse relationship, because more less, this is more. So these things are very important to interpret the association between one's analysis. If you our measures of association is relative risk, we will take this one. If you measures are odds ratio, we will take this one. If our measure is attributable risk, like experimental study, we will use attributable risk. So this keeping in mind, it's very essential concepts. So thank you very much for your attention. This is all about chapter 7, which is about measures of association. So now we have covered about measures of association like odds ratio and its interpretation, how to calculate odds ratio, concepts of odds ratio, how to interpret odds ratio, and also its interpretation. The second one is that how to the concepts of relative risk, how to calculate relative risk and its interpretation. And the third one is that attributable risk and its concept, calculation and interpretation. And the fourth one is that attributable risk percent, its concept, calculation and its interpretation. The fifth one is that population attributable risk, so and its concept, calculation and interpretation. And the last one is that population attributable risk percent. This is also we have seen about the three things, which is calculation, concepts and interpretation. So this is all about chapter 7, which is measures of association. So to get the next chapters, measure any evidence and causality, don't forget to subscribe this channel. And this channel will be released about the analysis, about some courses and different type of courses by experts in the field. So thank you very much for your attention and for watching this video. Don't forget to subscribe this channel. Have a nice time. Bye bye.